Good morning. The recording has just started. So, we have completed Spark session 1, session 2 successfully. So, we understood what is RDD. We understood how to write RDDs programmatically. You understood what is sc.parallelize. You understood what is sc.text file. You understood what is Spark driver. You understood what is Spark executor. You also understood how the data files are broken into blocks sitting across the nodes in the cluster, and how Spark reads those blocks as different partitions. Okay. Now, here with this example we discussed yesterday, this example, the final statement what I would like to make is one RDD was created from two files. These two files, which are split across three HDFS data nodes, which is nothing but as blocks. This will be existing in memory as three partitions, which a Spark application can then continue to use. Try to understand the fact that these blocks will be in memory till the transformation has been applied. Once the transformation is applied and then sent to action, that will be written to disk. That is what I was wanted to highlight. Now let's jump into RDD operations. You need to question, why the hell are you doing RDDs? What is the scope of RDD? Okay, why are we creating RDDs? What are we going to achieve by creating RDDs? Because we have to perform several operations, several transformations, several actions on top of RDDs. So once RDDs are created, there are two partitions that can be performed on it. One is actions, second is transformations. Now, transformations take the existing RDD, applies a function to elements of RDD, and creates a new RDD comprised of transformed elements. Now, I have 1 to 100. That is my data set, which is the resilient distribution data set. I'm going to apply a transformation on that, filtering all the numbers that are equivalent to my hall ticket number, 420, 520, 620, 720, like that. So when I apply a transformation, my first data set will be 100, 1 to 1000, and then my newly transformed data set will be 120, 120, 220, 320, 420, 520, 620, 720, 820, 920, 1020. So 10. The first set of 100, first set of 1000 in one data set are transformed, a business transformation is applied, and then newly formed RDDs are pushed into an other RDD. That is what we call as mutable and immutable. Immutable means, if you remember here, I have very clearly explained you. Immutable is nothing but a newly formed transformation. The RDDs that are newly formed when something is changed are called immutable RDDs. Okay. See here, I have given you this yesterday also, but I want to tell you very clearly. If you see here, I'm not doing anything. I have opened. I will show you once again. Recording started. Yeah, very good. See, exit. Quit. I came from Scala. Now, if you say Scala, welcome to Scala 2.1.8. Cool. Now see, 1 plus 2. I'm not giving int I. I'm not giving anything. It is automatically taking 1 equal to 2. Okay. Val a equal to ThoughtWorks. Okay. Okay. If I say var, let's see what happens. It's not taking it. Val a equal to now it has taken. See, do you see that it has given val a equal to h is character h. If I do the same thing with colon, it will take it. Why it is taking H but it's not taking ThoughtWorks? What's the problem? Okay, that's fine. See, my idea is to explain you what is immutable and mutable. So if I say val a equal to H, you are defining a variable, and for that variable you are assigning a value H. Okay, it has taken perfectly. Now if you see here, a equal to B, it failed because reassignment to val. Okay, if you see var a equal to H, okay, now again a equal to B, it taken. Do you see that? That is the difference between val and var, immutable and mutable. This is very important question. I am sure when you say you have worked on Spark, they'll definitely ask you a question on, have you worked on immutable and mutable variables of data elements of Spark? You have to tell them, yes, I have worked on them. I have a very clear picture on it. This is nothing but your data files will be broken into blocks, and those blocks will be splitted across your data nodes. When Spark collects this RDD as partitions, and when a change occurs on these partitions, this will be moved into a new partition rather than having the change in the same partition. For example, here initially a equal to H. It has taken a equal to H perfectly. Okay, for the same a, I assign value B. It has not changed, so this is mutable. Now if you see here, val a equal to H, and I try to assign a equal to B, it didn't allow me because it is immutable. Okay, it says reassignment to value failed. That is what it is. That is the difference between mutable and immutable. Okay, yesterday I tried to explain it, but I thought I shouldn't confuse you very early. Now coming back, you understood this, right? One RDD was created from two files which are split across. This is a very important thing. That's the reason I highlighted it. Now, the hypothetical cluster has two RDDs. Each RDD is composed of multiple partitions. That's right, which are distributed across the cluster. RDD can contain any type of, guys, one thing, you may think this is theoretical, but every statement what I have given here is a bullet point. The most out of a book I made the slides. Out of Spark guide I made these slides, so all the important points are here. This will enhance your way of understanding, so kindly you have to bear with me as it's been theoretical session and I'm trying to show every theoretical part practically. Okay, see, RDDs can contain a serializable element. For example, any data type can be converted to any other data type through Spark. Okay, that is the reason why they're telling RDD can contain any type of serializable elements, meaning those that can be converted to and from a byte stream. Int, float, bool, sequence, iteratives, arrays, list tuples. In this thing, anything can convert it to anything. Okay, elements of RDD can be mixed as well. Means you can have ABCD, you can have one, you can have int, you can have float, you can have double, you can have character, timestamp, anything. For example, an array or list can contain both string and int values. Furthermore, RDD types are converted implicitly when possibly, meaning there is no need to explicitly specify the RDD creation. That's what it is. Okay, I'm not going fast. This thing I have already highlighted. That is the reason why I'm just walking through it. RDD types are converted implicitly when possible. Okay, meaning there is no need to explicitly specify the type during RDD creation. That is what I was doing here, right? I just did, if you see here, I just did 1 plus 2. I didn't say int I equal to 1 and 1 isn't, 2 isn't, count 1 plus. I have not done that. I just did 1 plus 2. That's it. It has taken and it given me a variable containing int equal to 3. So it has the capability to interpret what the data type is. Okay, that's what it is. You understood the important concept now. That's nice. This slide, I'll show you. I thought to tell you this today itself, but this is the most important part of your development skills. You have a process called IDE tools, IntelliJ, STS, you write a code and you write important part of it. To write a code you need an IDE. So I'll show you this over the weekend. I thought to do it today itself. I prepared a notes also, but it will be too early. So Saturday morning we'll have a long session. That time I will install it here, and you will be installing on your machines parallelly, and you will write a code by yourself. Okay, this is all that one. The whole concept of installing IDEs, what are things you need to do, what is a maven build, how you set up Scala, how you create a Spark application, and how you set up an SBT. All these things I have made a note of it, so we can go ahead on that one. This is done. Now, RDD operations. Transformations take an existing RDD, applying a functions to element of RDD, creating a new RDD comprised of transformed elements. That is mutable and immutable. That's the reason I have to go back, explain, and come here. An action result set of functions applied to the element of RDD in the form of screen output, a file, write, etc. Very good. That's nice. So you understand the difference with transformation. Transformation is nothing but on your set of RDD or elements, you are applying a transformation. The transformed elements are written to a new RDD. That's it. There ends the story. Action is the result of the transformed RDD written to a disk or written to a REPL or written to somewhere else. Okay. Now, Spark programming basics, guys. You need to understand. You need to understand this bit very carefully. Spark makes heavy use of functional programming that does not rely on data outside of the function being executed, nor does it modify data that exists outside of the current function. That is the functional programming. Can you make a note of it? Let me definitely ask you, have you worked on Spark or have you worked on Spark functional programming? You have to say, I have worked on Spark as a functional programming aspect of it. Means everything you do in Spark is within the RDD, within the function, but not outside of the function being executed. For example, if you see Java, you have functions called inside, outside, left side, right side, everywhere. You can call functions globally also. But here, you will call everything within the function. I want everyone to make a note of it, please. Very, very important. Please write this down. Let me know once done. Done?
Yes, Samar, it's done.
Cool. Perfect. Thanks. So now what happens is, let's see an example of this one. Okay, understanding practical and theory is important. We define a variable outside of your function, then pull that value into your function and modify it. Note that dependency on and the writing to a variable that exists external to function itself. Now, where value equal to 0 is a value you are defining to a variable. This is the function name. Def is definition function. Okay, and the function name is unfunctional code, and this is the parenthesis of it. Now you are defining a global var variable. Okay, this var variable is equal to, okay, this initialized variable value plus 1. Now this is the standard legacy way of doing it. Now let's see how this is written in the functional programming. This example, the variable value is instantiated as part of calling the function itself, and the only value within the function is modified. Def functional code var value, return var value plus 1. Guys, very simple guys, to not to confuse you. Every time when you write a function, you have a prefix called def. That is very clear. We are not concerned about this. This is legacy. This is the old way of doing it. Now the functional way of doing it is you define a function, okay, and this is the parenthesis of the function, means prefix of the function, and this is what you are going to do. This is important for you. And now you are returning this value plus 1. Earlier, first you have to initialize it and then define a function. On top of it, make it global and then count it. As we are talking about the example of functional programming, to explain practically how it relies on the function itself being executed and it does not modify anything outside the function, that's what it is. Dev functional code written val plus 1. That's it. Okay. Now, if you have any questions on this one, you can ask me. Anyone? Any questions on this one? Very basic, simple line. We are talking about functional programming. The functional programming means whatever you are doing, your programming or your plan of approach does not rely on data outside of the function, but it is within the function. That's it. Now, the need to operate on different partitions of the same RDD in parallel makes functional programming a requirement for Spark. Now people may ask you, why can't I work on Spark without functional programming? Why do you tell me the reason why you only using functional programming? You have to tell them, sir, as Spark is working on RDDs, RDDs are nothing but the files broken into blocks, and these blocks are sitting in different nodes. And every time when an RDD is reading a block from node, that is one partition. So your data is partitioned. Your RDD is a partition collection. So to operate different partitions, the functional programming is the best way of doing it. That is the reason why it has got following characteristics. That fact that characteristics are: RDD1A can be transformed to RDD1B, but an individual element of RDD1A cannot be independently modified. That's what I try to explain you here. This RDD is an independent element. If if I have done a transformation on it, I can assign the transform results to a new RDD. But without even doing any transformation, I tried to assign another variable to the RDD. What happened? It kicked me in immutable part of it. Immutable part of it, it didn't even care what I was doing. It has taken whatever I gave. Clear? Got it? What's your doubt here? Okay, guys. If you have any questions, let me know. This is very important. If you are confused, let's not move forward. If your foundation is not strong, you will end up with very bad Spark programmer. Don't do the mistake. I struggled initially a lot. Let's come back and revise if you want. But please make sure you understand basics very correctly. Did you understand what is a functional programming is? Did you understand what is immutable and mutable? Everyone, come on, open up. If you're not clear, just say I'm not clear. Perfect. Now, RDD1A is transferred to RDD1B. Okay. RDD means resilient distributed data set. But once that is transformed, it can be moved to transformed RDD1B. But individual element cannot be moved. Okay. No state or side effects. Okay. This means no interaction with or modification of any value or properties outside the function. Having said, this will be relied only on the data within the function. Okay. Behavioral consistency. If you pass the same value into a function multiple times, you will always get the same result. changing the order of evaluation does not change the result. Once again, 0 plus 1, 1 plus 0 is same. Okay, but 1 plus 1 and sorry, counting 0 with any number is the same result, but not counting 1 with other. Okay, like this behavior consistency, the same value to function multiple times will give same results. If you change the order of evaluation, that does not change your results. Functions as arguments. Function results include anonymous functions can be passed as input arguments to the functions. Lazy functions. Function arguments are not evaluated, executed until required. For example, your in-memory processing or your Spark in-memory processing will is very lazy. It won't do any evaluation. It just does, I have RDD. You are asking me to perform a transformation. I'll do it. That's all it does. There's nothing more it could do. Okay. Now, Lambda functions. Very, very important. Very, very important. The whole funda of Spark lies on this one. Okay. Anonymous functions, also called lambda functions, are used heavily in Spark programming. They start with the declaration of anonymous function. Okay, this is anonymous function. Okay, or how I can say is, 1 minute, guys. Somebody's pinging me. Guys, can you see my screen? Everyone, any problem?
No, Amar, it's fine.
Okay, cool, perfect. Thanks. Yeah, guys. Uh, I'm going very slowly. Okay, so please, this is very important. This concept, lambda architecture, lambda functions. Okay, now lambda functions are used heavily in Spark programming. Point number one. Everybody understood that. Point number two. They start with the declaration of anonymous function by using keyword lambda. Do you see that? This is lambda. Okay. Now, guys, let me go slowly. I'll explain you more nicely. Now, then the programmer provides the variable that will be used to the function body. Let me take a pen. Declaration of anonymous function lambda is done. Perfect. I agree. You understood that very nicely. Okay. Now, the programmer provides a variable name that will be used in the function body. This is the variable name programmer is using. Perfect. You understood that. Followed by a colon. This is the colon. Very good. Now, to right of the colon will be the function body. This is the function body. Okay. Now, which can be a function definition or a call to yet another function. This one, z plus 1, called here may be called anywhere else. That is the consequences of your functional programming. I repeat, lambda functions are that important. Without lambda functions, you can't even move a bit in Spark. You have to understand it very carefully. Lambda functions are heavily used in Spark functional programming. Step number 1 done. The way you give syntax is initially you'll initialize a variable. Okay, that variable is called for you declare anonymous function called lambda. This is your anonymous function. Okay, you defined it. Very good. Once you define this anonymous function, you define a variable that is z. Okay, after defining a variable, you use a colon, that is this one. This one. Okay, after that you have a function. That function is this one. So what do you know here? The way you define a lambda function in Spark is, first declare a variable, declare a function. After that declare a variable, assign a variable. Okay, colon, and then to right of the colon you have a function. This function will be used everywhere. Okay, now I'm going to show you practically about it. You are getting there. You started doing transformations now. Okay, please focus. Let me go to pointer. Now see. Now here is example using z as an anonymous function variable selected and applied to z plus 1 to all elements of RDD as an argument. Now this is my RDD. You know, for RDD also you need to give some name. You may not give some name also, just fine. Now sc.parallelize, you know what is sc.parallelize? Sc is spark context. Parallelize will create an RDD and your RDD is 5, 7, 11, 14. Perfect. Now you know your new RDD, can be a transformed RDD of A1. So this is the new RDD on which your old RDD, you are applying a map function and then a lambda function. Okay, you are initializing a z. Z is nothing but this bit, this bit, this bit, this bit. Z plus 1 is 5 plus 1 6, 7 plus 1 8, 11 plus 1 12, 14 plus 1 15. This is the result. Okay, I'll show you that. I will show you that. RDD numList equal to sc.parallelize parallelize. Please be careful. I shown you the difference. What happens if you do curly? What happens if you do square brackets and other things also? I'll say 1 2 3 4 5 6 7 8 9. Okay, that's done. Okay, what happened? Why is spelling mistake? Parallel. Parallelize. Wait, this is Scala, not Spark Shell. I have to open this one. Perfect. The difference is Spark Shell is a clustered, Scala is standalone. Okay, so you can't use that one in Scala. See guys, very simple. Sc.parallelize means you need to have Spark context. Okay, this is Scala. Okay, so if you open, see here I have a Spark context available as Sc, but here I won't have that one. That's the reason. Now I got Scala with Spark context. Now if I say RDD numList equal to sc.parallelize parallelize, on which I have 1 2 3 4 5 6 7 8 9. Okay, still it's showing error message. What's the reason? Let me take this out. Val RDD numList. Okay, got it. I must be using PySpark. Not this one. I'll show you the difference. Don't worry. I'll show you the difference between Python with Spark and the Python Scala with Spark. Okay, this context actually, this example was explained with Spark using Python. All this while I was using Scala. That is the problem. Now if you see here, I'll just say RDD numList equal to sc.parallelize. I always do that mistake, so I'm very careful in writing the. It took it. The reason why it has not taken here is this is Scala. In Scala, you always have to use val like this. Okay, that is the reason it's failing. I haven't used val and this is failed. In Python with Scala, which is PySpark, this bit you need not have to use val var. You can directly use the numList. Now if you say RDD numList dot collect, which is nothing but collects the RDD, it says 1 2 3 4 5. Now I'll say RDD transformed equal to rdd numList dot map function. On top of it, I have a lambda function. In lambda function, I'm defining a variable. After that, I have a function which is z plus 1. Okay. Now see what happens. Now rdd transformed, spelling mistake, transformed dot collect. See, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5. It incremented. Or you can directly do it here also. Dot collect. If it's not giving for I in rdd transformed dot collect, or let me do something for I in transformation dot take off 5. That's okay. It's a syntax error, not a problem. For now, we'll do it this way. Okay, this is done. 1 minute, guys. See, I'm not trying to confuse you. I just tried to collect directly, but it is not allowing. So I'll do it once again for you. I am removing this one, guys. Very simple. Let me explain example as is without any changes. Okay, this will be understood. You have called a function lambda. You have defined a variable. You have a colon and then plus 1. Okay. Now if I say rdd transformed dot collect, it gave me 2 3 4 5 6 8 9. That's all it is. Now we understood what is a lambda function. Okay. Now you can practice this one by yourself. Very simple. Initially you're creating an rdd by sc.parallelize. After that you're applying a transformation. It's a map function. You know what is a map function is. Map function just collects the data from all partitions and gives it to the rdd. On top of it, you have a lambda with a variable initialized and the function calling in it. Okay, very good. Now, basic Spark programming. Okay, 1 second, guys. I'll go on mute for 1 second. Bear with me. Okay, now, guys, now let's understand what is a basic Spark transformation is. Now, here, I'm taking a pen now. I explained you about lambda function. Where the hell is pen here? I explained you a lambda function. You understood what lambda function is. You should have questioned me what is map function is. Okay, we are going to talk about map function now. Without map function, okay, there is nothing. Though lambda function works on top of Spark, before lambda function has to be applied, there must be a map. Before lambda function has to be applied, there must be a map, because map is the one that puts all your data. What is a map? Google Maps take you to your location. It shows you the route. Like that, your partitioned RDDs, the partition data is now in RDD. Your RDD to be transformed, it has to know which is what. To put all the data set in an order, or to put them in a sequence. Your map function is the same like that. Let's understand that practically. Now, map transformation applies a function supplied as its argument to each element in RDD. Once again, try to understand. The map transformation applies a function supplied as its argument. Okay, this is the actual function, right? This is the actual function, right? This is the argument supplied to this action, this function, right? Am I right, guys? Lambda is a function and map is just one argument that is supplied to a function. You all agree with me? You got the concept? Now let's understand with an example. We have a list of numbers that make up our RDD, okay, and then we apply a map function and instruct Spark to run an anonymous function. Now, using z as a variable name for each element z plus 1 and immediately print out results. Okay, see, before you apply this function, you applied a map function, because map function is the argument that is given, which will put the sequence or data elements in an order. So the lambda function can be applied on the sequentially ordered elements of the data set. Okay, that's what it is. Am I clear now? Did you understand what is a map and what is a lambda? Everyone, guys, any questions till this point? Perfect, that's good. Now let's go a little deep into this one. Now, maps can be applied to strings as well. Here is the example. Now if I say rdd amarnath sc.txt file, I'll put all these things there. Okay, I'll show you a real-time example now. Okay, rdd amarnath is equal to uh, this bit and this bit. I'll paste it here. Invalid syntax, that's okay, that didn't work. rdd amarnath is equal to, if you see here, I'll do something, exit from here, okay, or exit. Now if I say Hadoop fs minus ls, let me go to user Hadoop ThoughtWorks. Now here, okay, ls minus l, local, I'm a gateway node, pwd home Hadoop ThoughtWorks vi amarnath.txt. okay, I'm creating a file. What are the contents of the file? This is the content of the file. Try to understand something. I'm just putting this file in HDFS. That's it. Amarnath was training Hadoop. He wanted to make Spark easy to his trainees. Everything is going well as per the plan. They're all desperate and committed. Okay. There's no full stop here. There's no full stop. Intentionally, I have not full stop. Okay. Now WQ. Done deal. Now ls minus l. You have amarnath.txt. Now Hadoop fs minus put amarnath.txt to user Hadoop thoughtworks. Okay, now this local file is now put into Hadoop. Now if I say Hadoop fs minus cat user Hadoop thoughtworks amarnath.txt. Perfect. It took perfect. Now I'll go to PySpark. Very good. I understood that perfectly. Now if I say rdd amarnath equal to sc.text file. Where is your text file? User Hadoop thoughtworks. In that you have amarnath.txt. Okay, just check once again. rdd amarnath dot collect statement. Before you go to next step, always check first step. Okay, now if you see here, understand something. This is one element, because see, this is key, this is value. Okay, this is other element, this is other element, this is other element. So with this one, each line is taken as one element of your rdd. Till this point we are clear. Now let's go back. Now RDDs created using text file method treat new line character as a character that separate elements. So this is line 1, this is line 2, element 2, this is element 3, this is element 4. Right? Agree with me? Agree with me everyone? Okay, now because of this, what happens is, since this file had 4 lines, the files are shown in the image would have 4 elements in RDD. Okay, now if you see here, it has 4 elements. This is 1 element, 2 element, 3 element, and 4 element. Very good. Now if I apply a lambda function on top of it, if I say rdd amarnath line equal to rdd amarnath dot map function, on top of it I have lambda function. Okay, and in lambda function I say line, and after that I say line dot split. How am I splitting it? I am splitting it with comma separated value. Always remember, between your line and this there should be space. Line dot split. I'll show you what I'm doing. I'm splitting with empty space. Okay, this is done. Now rdd amarnath line dot collect. Do you see that, guys? Very simple, guys. Very simple. This is your already created RDD, and this is,
it's 6 o'clock.
That's fine. That's fine. Chill now. Okay. This is, that scared me. Sorry for that. This is your RDD, right? This is the result of your RDD, right? You are with me, right? Now I'm applying a lambda function. Before applying a lambda function, I gave a map as what I can say. What is the term called? I said something here. Argument. Sorry, yeah, I forgot the term argument. Okay, I gave argument as map, and in lambda function, I'm initializing a variable called line. What is line? This is one line. This is one line. This is other line. So I have 4 lines. So I'm going to apply this lambda function on each line, and for each line Okay, let me take a pen and show you. Guys, is it interesting? Now, if you see here, line 1, line 1 minute, guys. Why pen is not working? 1 minute. Let me clear it off and try again. Erase all drawings. Choose pen. No. This is line 1. This is line 2. So now this lambda function you are applying on line. Okay. On each line, split it with space. Okay. When I split this line with space, I have space here. I have space here. Wait. I have space here. I have space here. So this big element will be now broken into 4 elements. Amarnath is one element, was is one element, training is one element, Hadoop is one element. So Amarnath, was, training, Hadoop. If you see here, within one RDD, earlier, if you see here, you have U, right? This is one data element, and now this data element is broken into parts. Okay, like that. This is also broken into parts. This is also broken into parts. This is also broken into parts. That is what your Spark can transform the data. Okay. Now what I want to understand is a map transformation is then called. Okay. The goal of the map transformation in this scenario is to take each element, which is a string containing multiple words, and break it up into array that is stored in a new RDD for further processing. Now, guys, now what is array? This is array. Earlier, this is one element of RDD. This element of RDD is broken into an array. Okay, this kind of breaking your data and transforming your data, you are using Spark with lambda functions, calling them anonymously. Okay, argument map, our sole purpose is to create elements or break that elements into data set that is ready for processing. Okay, once again, I'll give this here. You can make a note of it. These are all very important. Though you have slides with you, where is chat window here? Yeah, it's here. Can you make a note quickly? Guys, very simple. If somebody asks you, tell them, boss, my map function maps my data. That is nothing but one element will be broken into array. Let me once you're done. And to break it further, let's understand the split function also. Let me once done, understand the concept carefully. Let me know once done. Quick enough, quickly. Guys, come on. Is it done or not? It's just one, two sentences. Hello?
Amar, it is done, Amar.
Okay, cool. Yeah, that's fine. Perfect. Thanks, thanks, thanks. Now, where am I? I'm in the basic transformation. I have explained you map function very nicely. Now, flat map. Flat map. See, there's one thin line difference between map and flat map. It seems to be theoretical, but you have to understand practically, which I'll show you. Now, what is a map function? Map function is simply converting your elements of an RDD into array. To explain more deeply, each line is one element. That one element is broken into array, splitting by space. So ideally, your map function says this is 0, this is 1, this is 2, this is 3, or 1, 2, 3, 4. For 1, this is key, this is value. For 2, this is key, this is value. For 3, this is 3, this is key, this is value. That's how it takes. Now let's understand flat map. Very important. The flat map is very similar to map function. Very good. With the exception that it performs an extra step to break down or flattens the component parts of elements such as arrays or other sequences into individual elements after running a map function. Okay. Now without going into theory, let's see what happens to flat map. See guys, I'm showing you once again. This is my RDD, right? Observe carefully. No, no, wait. This is my RDD. Perfect. RDD Amarnath dot collect. I have 4 elements now. Okay. If you observe carefully, I am applying a map function on top of this one. My map function is nothing but I'm splitting the line with space. Okay. Very good. Now, if you see Amarnath line dot collect, your element is broken into array. Now, I'll do the same thing, but I'll use flat map. For flat map, what you have to do is FLAT and M must be uppercase if I'm not wrong. No, it's not uppercase. Sorry for that. My bad memory. Okay. It is uppercase actually. I have to correct it there also. Yeah. Let me correct it here also. Okay, done. Now if I say RDD Amarnath line dot collect, see what it has done. If you see here guys, there is no big difference between map and flat map. The only difference is if there is a possibility to break the, see, first thing is elements converted to array, right? If there is any possibility, these elements can further be formed as an, this array can further be formed as an element if possible. That is what the flat map does. Okay. So by this practical part, you understood there is no difference between map and flat map. Both are same. Okay. Now understand the concept. The flat map function is similar to map function with the exception that a flat map can perform an extra step to break down the component part of elements such as array or other sequences into individual elements. Okay, now this is one element, right? Where is it? This one element is broken into array. If there is any possibility for your transformation, if that needed only an element, it can further break down or flatten uh, this array into element. That is only for processing. Your map function very well knows where to do what based upon the transformation you're going to apply. So all you need to do is you have to know where to use map and where to use flat map, which we'll be discussing practically next 2 minutes. Okay, that is one area of it. Okay, map is one to one transformation. One element comes in, one element goes out. Okay, using map, 4 lines were converted into 4 array elements. You are with me in that, but we still started and ended with same number of elements. Okay, but the important point here is the flat map function on other hand is one to possibly many transformations. One element may go in but many may come out. Okay, now if I apply the same thing on my flat file, the output written as a single list of individual elements rather than 4 list of elements that were originally separated by the break line. Now if you see here, how I can explain that? How I can explain that? I'm just thinking how I can differentiate it properly. Okay, so see here, your map function, right? Guys, please focus. Please focus. Everyone, please focus. This map function, okay? It broken. It broken your list of elements to array. I agree. But one thing you have to observe is within this list, you have 4 arrays. Within this list, you have 4 arrays. Sorry, this many arrays. Okay? With this list, you have this many arrays. But have a look on the flat map. Your array started here and ended here. Is that okay? You understood the difference? That's what I was trying to explain in this line. The output written as a single list of individual elements rather than 4 list of elements. Okay? This is one list of element ideally, but your elements are broken into arrays inside the list. Here also it is one list, but the elements present inside the list is an array. Okay, this one is also other list but an array inside. This is also one list but an array inside. So your map function has 4 inputs broken into 4 lists having arrays inside. But what your flat map has done, it has flattened all the data. It has flattened all your 4 inputs into one single input. It can be done vice versa also. Map is one to one, but flat map is one to many. It has flattened everything. It has converted all the 4 elements into one single element having arrays in it. Clear till this point, everyone? Now, this time the results of each word is being treated as its own element. That's correct. So this is all one element and all the values in this element are considered as arrays of its own. Okay, again, it is easiest to think about flat map as simply as map operation followed by a flatten operation in a single step. As simple as it is always easy to think flat map as one step on top of map function which flattens everything. Clear till this point, everyone? Any questions? Hope you're enjoying it. Any questions, let me know. Any questions, let me know. I'm going very, very slowly, ensuring you should have enough time to practice and you should have enough time to understand. You should understand a flat function. You should understand what is a map function, what is a map, what is a map, what is flat map, what is lambda, and how lambda function will be called, what is an anonymous function, and how a map function can be defined before you give anonymous function, how the argument of map is supplied. Are you sure you have no questions, everyone? Guys?
Not at this point, Amar.
Perfect. That's all I have for today. I don't want to dump everything. You understood very nicely map, flat map. Tomorrow we'll discuss filter, distant, and other basic operations. I'll try to complete this all theory stuff by Friday. And Saturday morning, I'm going to have a very long session wherein we'll install Scala on your local machine, on your Windows or on your Mac. Agenda number one. Agenda number two, you'll have IDE tools. IDE means integrated development environments like STS, Eclipse, or IntelliJ. Have try to Google what is IntelliJ, what is Eclipse, how programmers use them. Once we install them, we'll jump into this bit, and I may have a good news by end of today for the certification part of it for you guys. Once I have an update, I'll let you know. I was just waiting for them to confirm today because other batches are all certified. I want these guys also to help on that one. Okay, I'll let you know by end of today. I'm just waiting for that guys to come back. Anything else you have? Any other questions? Anyone? Are you enjoying this? Are you understanding that you are coming to you're going to some destination on Spark? Okay, guys, that's all I have for today. See you all tomorrow. Have a great day. Enjoy your work. Thank you.
Thanks, Amar.